Antisymmetric is if A is related to B and B is related to A, then A is equal to B. Okay? Or in other words, you can write this is P implies Q. No? So you can write equivalent statement, that is a contrapositive, right? So this will be for not equal pairs, for any two pair A comma B, if they are not equal, then negation of this thing means negation of this one or negation of this one. Then either A is not related to B or B is not related to A. Okay, clear? This is your antisymmetricity. Now consider these relations. Tell me whether these are reflexive, symmetric, transitive, antisymmetric or not. Relation are R1 given by R1, R2 and R3. Yes, tell me.
Ma'am, not reflexive.
Not reflexive,
Not
why not?
reflexive.
3, 3 pair is
Because
there.
3
3
is not
comma 3 is
related to
not
4.
present. So for reflexivity, A should relate to A for all elements, right? So 3 comma 3 is not present, that's why not reflexive, okay? The first one, not reflexive. Symmetric,
No, ma'am, not
No, not
symmetric.
not symmetric, why not? For 3
Ma'am,
is
no.
3
not
is
present.
related to 4, but 4 is not
But
related to 3.
ma'am,
Yeah.
similarly, 4 is related to 1.
Similarly, 1, 4 is not related, right? So not symmetric. What about transitivity?
No, ma'am, not transitive.
Not transitive, many elements are not there. That's why 4, 2 is not there, 3, 1 is not there, right? You have 3, 4, 4, 1, right? So 3, 1 should be there, no? But it is not. 4, 1, 1, 2. 4, 2 is not there, right? So not transitive. What about antisymmetric? Antisymmetric means for not equality, you will look at all those pairs A comma B where A and B are not equal. Okay, A and B are not equal. For those, either A is not related to B or B is not related to A. But in this case, it is right. AB is present. B that is AB is related. A is related to B. B is related to A. But A and B are not equal, right? In this one, by the first definition, or you can apply the second definition also. Correct? This is not antisymmetric. Now R2.
Ma'am, not reflexive.
Not
Not
reflexive.
reflexive.
Only one is
Yes,
present.
ma'am.
Rest of 3 pairs are not present, so not reflexive.
Ma'am,
Symmetric.
symmetric.
It is symmetric because 1, 2 is there. Oh, is it symmetric?
Yes, ma'am.
Yes, ma'am.
So you are
Yes,
saying
ma'am.
1, 2 is present, 2, 1 is present, so 1, 1 should be present, and that is present over here, right?
Yes, ma'am.
But what about if I write this as first 2, 1 is present, 1, 2 is present, then 2, 2 is present. 2, 1 belongs to this
Symmetric.
set, 1 comma 2 is belonging to this set, then it should be the case that 2 cross 2, sorry, 2 comma 2, not cross, 2 comma 2 belongs to that set.
Ma'am, it is a definition of transitive now.
Yeah, transitivity.
Yes, ma'am, we are saying that it's symmetric.
Symmetric,
Means
yeah,
you asked about symmetry. Yes, ma'am.
it is symmetric. Transitivity,
No, ma'am,
No,
not transitive.
It's not
not
transitive.
transitive, right?
ma'am, now it is transitive, but in that case, it will not.
Now it is transitive. How?
In the
One comma
two case.
one is there, then 1 comma 1 is also there.
1 comma 1 is also there, but 2 comma 2 should also be there, now. You getting it? See, 2 1 is there, 1 2 is there, right? So A B comma C, right? So A C should be present, but 2 2 is not there, na? Are you getting it?
Yes, ma'am.
That's why it is not
So, ma'am,
transitive. What
both
about
the conditions should be satisfied.
both of condition?
Ma'am, 1 1 will be there and 2 2 will be there. Both will be there.
Yeah,
Then would be
both. One more element should be there. If 2 2 would be present, then it is that transitive. But now
okay,
it's
ma'am.
not. Okay.
Ma'am, we would check both sides.
Yeah, both sides. See, for any ABC, na, for any ABC, if you consider A as 2, B as 1, then so
Ma'am,
B
if we
is 1, C is again 2.
ma'am, if we consider A as 1, B as 2, and then C as 1, then
Yeah.
it is transitive.
Yeah, see, for A as 1, B as 2, C as 1, this belongs to 1 1 belongs to this one. That is, for that pair ABC, AC is belong to this one, right? But what if I take this as first, this as second, right? Then 2 2 should be also there, na? By either side, you look at it and transitivity should hold. But here, it doesn't hold. Look at 2 1, right? Then 1 2. So if it would be transitive, then it should be 2 comma 2 also should be there, right?
Yes, ma'am. And this
That's
is
why
an
it is.
ordered collection of objects. That's why we have to check both the sides.
Uh, again, can you repeat the definition?
Ma'am, set is an unordered collection of objects.
Yeah,
That's
unordered. Yes, unordered. That's why order doesn't matter, no? Yeah, obviously A comma B, you can't write B comma A, but this is one element, na? This is one element. So you can write this element over here and this whole element over here, right? Okay.
yes, ma'am.
You can't change these element as if AB is present, this you can shift over here, but you can't write B comma A, right? These may not be same, but obviously you can place any element anywhere, doesn't matter. So I hope you got it why it is not transitive. We've given the counter example that we have this AB, B comma C, then AC is not present, right? What about R3? Before going to R3, what about antisymmetricity of this relation?
No,
Does
ma'am, not
it?
antisymmetric.
Not antisymmetric, right? So
Yes.
for different element, for different A and B, either this should not be there, means, or this should not be there, or both should not be there, right? But here both are present, na? Okay,
Yes, ma'am.
that's why it is not antisymmetric. What about this one? Reflexive? 1 1,
Yes,
2 2,
reflexive.
3 3 4.
Reflexive.
Reflexive. Symmetric?
Yes, ma'am. Symmetric.
1 2 is there, 2 1. 1 4 4 1. Yeah. So symmetric. Transitive?
Yes, ma'am, transitive.
Transitive. Look at all the pairs. 1, 2, 2, 1, 1, 1 is there, 2, 1, 2 is there, 1, 4, yeah, it is there. So all the pairs satisfying the thing, right? So it will be transitive. What about antisymmetricity?
No, ma'am, not antisymmetric.
Not, right? We have both for not equality. 1, 2 is there and 2, 1 is there, right? Okay. R4. This was not antisymmetric. Yeah. Reflexivity.
Not reflexive.
Not reflexive, right? It is not reflexive. So all pairs, all same pairs are not present. That's why not reflexive. What else?
Ma'am, not symmetric.
Not symmetric. 2, 1 is there, 1, 2 is not there, right? 3, 1, 1, 3 is not there. So not symmetric. Transitive?
Not transitive.
Not transitive. Give me the counter
Transitive.
example.
Ma'am, transitive.
Ma'am, transitive.
Transitive. So 2, 1, 1 is not there. Okay. So 3, 1, 1 is not there. Then 3, 2. 3, 2, 2, 1, 3, 1. That is present. Then 4, 1. So now 4, 2. If you take as 4, 2, then 4, 2, 2, 1. So it will be
Ma'am, 4, 1 is
4, 1,
present.
right? 4 is, and here 4, 3. In case of 4, 3, it is 4, 1 as well as 4, 2. For these two. So this is transitive. What about antisymmetric?
Ma'am,
Is this
can you
antisymmetric?
explain the antisymmetric once again? I didn't get it.
See, in antisymmetric, if your AB is there, okay, A is related to B and B is related to A, okay, then it should be the condition that both are same. Means to say, for not equality A and B, right? If you have these two ordered pairs, for not where A and B are not equal, okay, then either these are not related or these are not related. Means to say, out of AB and BA, at least one pair should not be there. Okay,
Okay, ma'am.
got it?
Got it, ma'am.
Okay. Yeah, antisymmetricity. Here you have 2, 1. So 1, 2 is not there. So at least 1 should not be there. That's okay. 3, 1 is not there. 2, 3 is not there. So
Antisymmetric.
neither of
ma'am.
B is not there. So this is antisymmetric. What about R5? Reflexive? Yes. Reflexive, right? 1, 1, 2, 2, 3, 3, 4, 4. Symmetric?
No, ma'am.
Why not?
Ma'am, 1, 2 is there, but 2, 1 is not there.
Yeah. 1, 2 is there, 2, 1 is not there. And like this, 3, 1, 1, 3. 1, 3 is there, 3, 1 is not there. So not symmetric. What about transitivity?
No, ma'am, not transitive.
Not transitive. Why is it so? Can you give me counterexample?
Ma'am, 1, 2 is
Ma'am,
there and 2,
transitive.
2 is there, but 1, 2 is not. Wait, wait, wait.
Yeah, this
Ma'am,
is there.
transitive, ma'am. Transitive.
It is 1, 1, 1, 2, 1, 2 is present. 1, 1, 1, 3 is present. 1, 4 present. Then you can take this one. 1, 2, 2, 2. Okay. 1, 2, 2, 3. 1, 3 is present. 1, 2, 2, 4. 1, 4 is present.
3, 4 is not there.
3, 4, this one. 1 3 1 3 3 3 1 3 is there. 1 3 3 4 1 4 is there, right? So this is transitive, right?
Yes,
What
ma'am.
about
Transitive.
antisymmetry?
Ma'am, in the transitive, we took 1 3 and 3. Sorry, just a minute. I will again think and ask.
I think you wanted to ask 1 3 and 3 3 is there, then 1 3 is again present, or 1 3
Yes,
3
ma'am.
4
Yes, ma'am.
is present. 1 3 and 3 4 is present. So from here it will come as 1 4. That is also present.
Yes, ma'am. That was I was asking.
Yeah. So 1 3 is there. Transitivity.
So first
Right?
first one that we took as given, then we can repeat and take it as answer.
Obviously, that means that should be present in R now. That can be the same thing,
Yes,
whatever
ma'am.
we took, right?
Yes, ma'am. Got it.
Okay. What about antisymmetricity? Is it
Yes, ma'am.
antisymmetry?
Yes, ma'am.
Means the if for same product same this reflexive AA can be present all AA for all A, but for different A and B, the that is at least one the other pair, that is at least one pair should not be related. Okay, should not be present in R. Okay, so either both are not there or at least one is not there. Okay, one is not there. 1 2 2 1 is not there. 1 3 3 1 1 4 4 1 is not there. 2 2 it's okay. 2 3 4 2 3 3 2 no. 2 4 4 2 no. Then this is okay. 3 4 4 3 no, right? So this is antisymmetry. Okay, got it?
Yes,
Or
ma'am.
still confused about antisymmetricity? Okay, then go ahead. R6, tell me.
Only antisymmetric.
Only antisymmetric.
Only antisymmetric, right? It's not reflexive, not symmetric, not not transitive. Why this is not transitive? Tell me.
Ma'am, transitive.
Only
Transitive. It is transitive. Transitive and it is not reflexive, not symmetric, transitive and antisymmetric. For transitivity, two pairs should be there, na? We have only one pair. Okay, A, B, comma, A, B should
B.
be there, B, comma, C should be there, then AC. But here we have only one pair,
Ma'am,
right?
can you explain the antisymmetricity for this 3,4?
Antisymmetricity. See, 3 4 is there, but 4 3 is not there, right? So for not equal, A and B are not equal, na? So at least one should not be related to the other one. Either both are not there, that is AB and BA both are not present, or at least one should be there. Okay, sorry, should not be present in the relation. Okay, so 3 is not equal to 4, right? For not equality, 3 comma 4, either 3 comma 4 is not present or 4 comma 3 is not present. Okay,
Yes, ma'am.
it is not belong to. Are you getting it?
Yes,
Yes,
ma'am.
So at least one of these pairs should not be present in relation. So we have, correct. So the last one was not reflexive, not uh, symmetric, but it is transitive and antisymmetric. Okay.
ma'am, in that last part, only one pair is there. So in transitive, we need three things, no? A, B, and C.
Yes, yes.
Then what we will do in for this case, we will assume only A for one pair, and other B and C. What we will do for that?
So if we don't have the extra pair, then let it be, right? So if for transitivity, what should be there? A comma B present, then this B should be present in the other pair, whatever you are taking. Okay. We don't care about A, we don't care about C, but B should be matching, right? Right? So for
Yes,
this
ma'am.
one, for any three belongs to that relation, then we say if these two are belonging to that relation, then we say A comma C belongs to that relation. But here we don't have any other 4 comma something, right? So A is 3, B is 4, and we can't take 3 4 again, right?
Yes, ma'am.
That's why. That is, we have just one pair. I hope everyone got it. Yes. What about this one? Is a divides relation on set of positive integers reflexive? Okay, tell me about reflexivity of this relation. Symmetricity, antisymmetricity, transitivity. Yeah,
Ma'am, reflexive.
reflexive. So every positive integer divides itself, right? We don't have 0 here. If it would be non-negative integer, then it would not be reflexive, right? Now it is 1, 1, 2, 2, and so on. Okay. So this is
Not,
reflexive. What about symmetricity?
not symmetric.
Not symmetric. For example, if A divides B, but B may not divide A. Okay, 2 divides 4, but 4 does not divide 2, right?
Ma'am, transitive.
Is it transitive? A divides B, B divides C, then obviously A will divide C. Transitive. Right? Divides relation is what? Ordered pair A comma B. That's that. Yeah. Tell me.
A divide B.
A divide B. Okay. This is the relation RAB or ARB, whatever. So here A divides B. A divides A for all positive integer. Okay. For all A belongs to positive integer. Then you have symmetricity. A divides B, but B may not divide A always, right? Then transitivity. A divides B, B divides C, then A will divide C. Right?
Yes, ma'am.
So this is true. Symmetricity is not true. So this is reflexive, transitive, but not symmetric. And what about antisymmetric?
Yes, ma'am. Antisymmetric.
It is antisymmetric, right? So for not equality, you have only one pair is present. That is, at least one pair is not present. That is the point. Okay. Uh, This is run. Symmetric, if AB is present, then this implies BA is present. Antisymmetric, for antisymmetric you have, if AB is present and BA both are present, then A should be equal to B. Okay? Or you can just write like this, for all A, for all B, AB belongs to R, conjunction with BA belongs to R, then you say A is equal to B. Or for not equality pairs, A not equal to B, either this should not be there, that is A is not related to B, or B is not related to A. This one, which are the relations from example 6.2 are symmetric, which are antisymmetric. So symmetric and antisymmetric we have done for this example number 6.2. Clear? Everything
Yes,
we
ma'am.
discussed, all four. So I hope no doubt in that. Yeah.
Ma'am,
Is it divides relation this onset of positive integer symmetric? Is it antisymmetric? This is done.
yes, ma'am.
Yeah. What you are asking? Someone asked something.
Yes, ma'am. Ma'am, I was asking that whether symmetricity and anti-symmetricity can exist simultaneously.
Yes. And only A is equal to B is there. That is only in case of reflexive. If A and B are not different, A is not equal to B, then it can be, right? Only the reflexive pairs are present, that is AA are present. In that case, symmetricity and antisymmetricity both exist together.
Okay.
Clear?
Okay. Yes, ma'am.
And
Thank you.
can you give me an example?
For example, you have on the same set you can have 1, 1, 2, 2, 3, 3, 4, 4, and the set is 1, 2, 3, 4. And this is the relation. So can you say this is symmetric,
Yes, ma'am.
antisymmetric,
Yes, ma'am.
right? So if you include some more, that is, if you include 2, 1, then it is antisymmetric but not symmetric, right? If you include 1, 2, then it is symmetric but not antisymmetric. Okay. I hope you got the difference for
Yes, ma'am.
why I'm emphasizing on A not equal to B again and again. So that's this condition only makes antisymmetric or symmetric. Okay. When only reflexive pairs are present, in that case, antisymmetricity and symmetricity exist together. Yeah, transitive relation is done. If AB is related, A is related to B, B is related to C, then A is related to C. Any pairs ABC. Okay. Now this one. Divides relation on set of positive integer is transitive. Again and again the same question. How to prove that? Divide relation on set of positive integer transitive.
Ma'am, we will take 3 arbitrary elements A, B, and C that belongs to R.
Yeah.
Ma'am, that
So
belongs to
A,
set
B
A.
and B comma C belongs to R. Okay. AB belongs to R means to say A divides B, and B comma C belongs to R means B divides C. Right? A divides B. What is the definition of this one? B will be equal to A into some K. Okay. And B divides C. Then C is the multiple of
B.
B, right? So K1, K2 you can just say, or LK you can consider B into K2. Okay. Now from this one, put value of B. C is equal to
A K1 K2.
A K1 into K2. Means C is the multiple of A, right? C is the multiple of A. That means A divides
Divide C.
A. I hope got it. Yeah. This one tell me. This is just counting how many reflexive relations are there on set with an element. Yeah. How many reflexive relations are?
N.
Okay. Total number of relations are. If I am not asking only about the relation that is reflexive, total number of relation, it will be 2
2 to the
raised to
power
power
N
n cross
square.
n square, right? So out of that, how many are reflexive?
Reflexive relation number will be N, no?
Why n?
Because
See, n
reflexive means
elements should be there, n pairs should be there. A1 is there, B1, right? B1 is related to B1 and so on, right? A1, A2, A3 and up to An. We have these elements. So A1 is related to itself, A2 is related to itself, and AI is related to AI, right?
yes, ma'am.
So if you means you need to take these n elements, whatever it is, n pair, right? An ordered pair will be there for reflexivity. And how many total number of elements in A cross A? Well, that is the subset of this one, right? Clear? How many elements? N square, na? So out of n square, n are fixed because we want this reflexive. Relation is reflexive. Yes? Understood or not?
I have a doubt, ma'am.
Tell me.
Ma'am, in reflexive, all the elements should have a pair. Like if in a set only 1 2 is there,
No,
and
no,
we
no.
have a
All the element.
means 1
That
1
means
and 2 2. 1
uh,
comma 2.
that is for all A is related to A. That is the reflexivity. But you were giving some example. Tell me.
Ma'am, I'm just giving that there is a relation on A cross A, and A has 1 and 2.
A has
So that means
1 and 3.
2. That 1 and
Okay,
2.
1, 2.
That means 1 comma 1 should also there, and 2 comma 2 should be
Yes,
both.
yes. All pairs. That is all elements should relate to itself, right? This is the main condition for reflexivity. Other element are coming. For example, it is 1 2. 1 2 is there. 1 2. If we consider 1 2 or not, that's up to us, right? But the minimum reflexivity condition is this one, no? For all A is related. Okay, A is related to A. Yes, these n elements are fixed. Getting or not?
Yes, ma'am.
Okay. So, and the extra element may come or may not come, that doesn't actually affect this reflexivity. Still, it will be reflexive, right? So, n elements are fixed. We will choose these one only, right? So, these n elements can be chosen in one way only. We'll choose this one, right? The other element, yeah. How many other elements can be chosen? The remaining elements are n square minus n. We have already taken n out, right? So n square minus n. How many subsets can be there? 2 raised to
2
power
to
n square
power.
minus n, right?
Yes, ma'am.
2 raised to power n square minus n. That is 2 raised to power n into n minus 1. Clear? That number of reflexive relation, and yeah, one way for choosing that, and these number of ways for choosing the rest of element, right? Finally, we got 2 raised to power n square minus n, or n into n minus 1. Any doubt? Yes.
No, ma'am.
Yes. As the relation is subset of A cross B or A cross A, that depending on the A and B, whether they are same or not. So here also the relation between A and B. So that should be also subset of, that R should be subset of A cross B, right?
Yes, ma'am.
Got it? So itself, relation itself is a set. So we can find union of two relations, these are sets only, intersection, this. Okay? We can subtract two relations and so on. So R1 is given, R2 is given. Take the union. In union, it will be 1, 1, 2, 2, 3, 3. Right?
1 to 1.
1, 2, 1, 3, 1, 4. That will be union. Intersection, 1, 1 only. Intersection of R1 and R2. Right? Now other elements common. What about this one? R1 minus R2. R1 minus R2. That means the elements which are present in R1 but not in R2. So that are 1, 1 is there. 2, 2. 2, 2 is not present in R2. So 2, 2.
1 3.
3, 3. Right? So both will be there. Okay? Now R2 minus R1. So 1, 1 is there. 1, 2, 1, 3, 1, 4. These three are not present there, right? Clear?
Yes, ma'am.
Okay. Then we have this composition relation. Before going to this one, let me come back to third exercise. Determine whether the relation R on set of all real number is reflexive, symmetric, antisymmetric, or transitive, where x and y are related if and only if x plus y is 0. So the first relation is given, this one. So first tell me, is it reflexive, symmetric, antisymmetric, or transitive?
I'm not reflexive.
Not reflexive, because except x and y 0, 0, you don't have this one, right? So you don't have x plus x is 0 for all x. That's why not reflexive. So first one is not reflexive.
And symmetric.
Symmetric, x plus y is equal to 0, so you can write y plus x is 0, right? Y commutative property. So this is done. What about x and y, x comma y belongs to R if you have x plus y, that is 0, xy belongs to R, xy related, right? Yx related. So y plus x, this one. From here, can you say x is equal to y? Can you say it? Does this imply
No, ma'am.
x is equal to y? No, right?
Mm.
So, is it antisymmetric or not?
No, ma'am, not antisymmetric.
Not antisymmetric.
I'm not
What about
transitive, ma'am.
transitive? Not transitive?
Yes, ma'am.
Yes, ma'am, not transitive.
Not transitive, right? X plus y is equal to 0, y plus z is equal to 0, then you can't say x plus z is equal to 0, right? xy belongs to R means to this one, yz belongs to R means this one. Then can you find somehow x plus y, x plus z is equal to 0? We are getting this minus z is equal to 0, right? But that does not give a relation according to our relation. So here it is not a transitive, not antisymmetric, not transitive. What about this one? Similarly, you can try this one. Okay, try it now only. So
Ma'am,
here
not reflexive.
what we have, x is equal to y plus y or x is equal to minus y. X is equal to plus y or x is equal to minus y. Tell me, is it reflexive? Obviously, x is equal to x. That is fine. Reflexive, right?
Yes, ma'am.
Ma'am, for x is equal to minus x, it is not reflexive, no?
Both conditions may not be satisfied. This is either or, right?
Okay, ma'am.
So one condition need to be satisfied, not both. So one done, then obviously that is done. What about symmetric? Obviously x is equal to y, so y is equal to x, right? So symmetric done. X is equal to minus y, so y is equal to minus x. Done, right? So reflexive done, symmetric done, anti-symmetric. You have xy, that is from here, yx, y is related to x, so y is equal to x, or y is equal to minus of x. Okay, so from here, can you say x is equal to y? So if you have this condition with this one, then x is equal to y, right? Yeah,
Yes, ma'am.
from here to here, x is equal to y, x is equal to minus x. From here to here, yes,
Y is equal.
y is equal to minus y, x is equal to minus x, you can say. From here to here, this is coming as x is equal to y, right? So either of these four satisfying this, right? Clear? So is it anti-symmetric? Anti-symmetric or not? Or
Yes,
you can
ma'am,
just say, yeah, antisymmetric. Or you can just say for not equality x not equal to y, at least one of them is not there, right? So this is antisymmetric. What about transitivity?
Transitive, ma'am.
Transitive. How? X, Y, Y, Z, right? Uh, Y, Z. Y is equal to minus Z. Yeah. So x is equal to y. If you pick up these, x is equal, y is equal to z. From here you get x is equal to z, right? So x is related to z. What about this one and this one? X is equal to y, y is equal to minus z. So this one or x is equal to minus z. So from here also x is equal to minus z. It will be coming from here. X is equal to z. It will come. So we are getting this one only. Transitive, right? Antisymmetric. Similarly, you can solve this x minus y is rational number, this one. And these are exercise for you. You can try it. If you don't get it, we can discuss in next class. Okay. So yeah. Is it reflexive, rational number?
yes, ma'am.
Reflexive. X minus x is 0. That is rational number. So for all x, it is reflexive. X minus x is rational number. Yeah. Then
Symmetric.
third trick. See, x minus y is rational, then if you take minus out, obviously that will be also rational, right?
Yes, sir.
So if x is related to y, then y is also related to x. Clear? Antisymmetricity.
Not antisymmetric, ma'am.
X minus y belongs to q, q is rational. Y minus z belongs to also q, right? Sorry, y minus x. We are going for antisymmetricity. Yeah. From here, can you say x is equal to y? May not, right? It may not be always. That is 1, 2, 1 minus 2 is rational number, 2 minus 1 is rational number, but 1 is not equal to 2. So not antisymmetric. What about transitivity?
I'm transitive.
Yes, ma'am.
It is
Transitive.
transitive. So here it will be x, y, y, z, right? Then x, z. If you add it, add two rational number, one rational number this one, another is this one. If you add two rational number, y getting cancelled with this one, x minus z, again rational number, right? So this means it is transitive. Clear? Clear
Yes,
or
ma'am.
not? So can you tell me about this one? Is it reflexive? This is the relation where x comma y, right, are related via the relation x is equal to 1. Means in this relation 1 comma y will be there only, right? 1 comma b or 1 comma y, right?
Ma'am, not reflexive.
Not reflexive, right? For all the real number, it is that is xx not present. What about symmetric?
No, ma'am,
It is
not
also not
symmetric.
symmetric. One y is present, but y1 is not present.
Yes, ma'am.
Clear? This will be present only in case of one thing, that is 1. If y is replaced with 1. Okay. What about
Anti-symmetric, ma'am.
anti-symmetric? Yeah, obviously
Yes, ma'am.
for not equality, you don't have y comma 1, right?
Yes. Ma'am, transitive also.
It is transitive. 1 comma y is there. Actually, 1 comma y is there, and y comma 1, this is y comma some other. This is possible if y is 1, right? For next one, 1 comma y, this you will pick up. Then what you will do with that c or z, you can just say 1 comma y and y comma z, right?
Ma'am, if we will take z is equal to y, then it is possible, no?
Z is equal to y. It is possible, but y is equal to 1. You need to take y is equal to 1. Because the condition is first element should be 1. So for second pair, first element should be 1. That's why I'm just taking 1, 1 with 1 and some other z. Right? This is the part of this one. This is the part of this one. Why we did this one? Because 1 here, 1 here. Right? So here it will be 1, 1, 1, 2. Like this 1, 1, 1, 3. 1, 1, 1, 4 and so on. Finally, what you got? 1, A, B, B, C. Right? Okay. So what you got? 1 comma 2. That is A comma C present in the relation. Right?
Yes, ma'am.
Okay. So this is antisymmetric. Antisymmetric. This one is
Transitive.
transitivity. Actually, transitive. Right? So any other doubt? Any other doubt? Tomorrow I'll start with composition of two relations or more. Okay, that's it for today. I stop here. If you have any doubt, you can ask me in next class. Thanks all.
Thank you, ma'am.
Thank you, ma'am.
Hello, good morning.
Good morning.
Good morning, sir.
Good morning. Good morning. Good morning. Just wait. Okay. So I think we have worked out example 7.14, isn't it?